Hi all, welcome to my channel. This is a continuation of design patterns playlist, and this is the last design patterns in the structural design patterns. Yes, by this video we are completing complete structural design patterns. I have already completed creational design patterns. I was completing structural design patterns also. If you missed those videos, I'll put the link in description, so please go and watch. And also please don't forget to like and subscribe to my channel for the future videos to come in. So the last design pattern is flyweight design pattern. Let's discuss about what is flyweight design pattern. Before talking about flyweights, so did you know how sharing will help you a lot in different circumstances? Sometimes sharing is the most important to sustain a situation where you are in group. Let's say when you play with your friends and you all share toys, they are video game. It might be video games, or it might be different kind of outdoor activities or indoor activities. So your toys last longer and you can play together for a longer time. So if you are playing in a group with the minimum number of the minimum number of toys, you entire team can play larger time, which means each toy is sharing by each person. So when it comes to computer terminology, you have certain set of toys, right? So more number of people are playing. So which means you are sharing the toys among different people, right? Which means you are efficiently using those toys. Let's convert this normal terminology into computer world. It helps you use your computer's memory more efficiently by sharing common information. If there is any common information which can be shared across different folders or different apps, that we can store in a separate objects, we can call as a flyweights. And those flyweights can be shared across all the wherever we want, so that the memory the memory consumption is reduced, and it will improve the performance also of computer. So that's it. That is nothing but a flyweight pattern. Let's go and discuss about standard definition of what is flyweight design pattern. So in a behavioral design pattern that lets you fit more objects into an available amount of RAM by sharing common parts of a state between multiple objects instead of keeping all data in each object. That is just I discussed it, right? So if there is a common, why can't we share? Let's share it. So flyweight is a shared object that can be used in multiple contexts simultaneously. The flyweights act as an independent object in each context. Flyweights cannot make assumptions about the context which they operate like. So there are two types of flyweights. One is two types of states are there. One is intrinsic state, and second thing is extrinsic state. So intrinsic state is nothing but a flyweights. We can store those state in a flyweight. Extrinsic state is something more explicit and more individual to the object itself, which cannot be shared in the flyweight. So intrinsic state refers to the information that is stored within the shared object, which is in common to all objects that use the shared object. This information is basically immutable, meaning it cannot be changed, and is usually shared among many objects to reduce the memory usage. Whereas an extrinsic state, on the other hand, refers to information that is unique to each individual object and cannot be shared among objects. So the information is stored outside of the shared object and passed as an argument to the methods on the shared object when needed. So which means that every time this extrinsic state might change, but intrinsic state won't change. So we are putting the intrinsic state into the flyweights, basically called shared objects. By separating the object state into intrinsic and extrinsic, the flyweight design pattern allows for a reduction in memory usage and improving the performance. So the intrinsic state is shared among multiple objects, and the extrinsic state is stored only of each individual object. So based on these assumptions, I have created a small program. If you're seeing this diagram, you might feel very similar like in my previous videos. Can you guess that one? Yes, it's a factory design pattern. This is exactly same class diagram I have taken from factory design pattern. Here also there is something called car. There is multiple cars might be there, like Amstelveen car or Porsche car, or some Lamborghini car, different types of car. And we are asking a car factory to give the car object. So if you see, there are in a car in a racing game there will be different cars, and also there is might be common cars. Let's say McLaren car might be used by 5 different racers. So we can store the entire object in the Flyweight itself, so that all McLaren cars can be become as a single McLaren car, and Porsche likewise. So that's a simple implementation. How we'll basically implement, how we will store, I already discussed in the factory design pattern only. We are using hash maps for the Flyweight pattern, or any data structure where the data should be cached and can be shared across all the objects by passing a key associated with it. And if the object has created, we simply get the reference of the object, else it creates a new object. This is exactly what we did in the factory design pattern, right? Only thing is we didn't actually return the already created object every time. We are creating every time new object. No, basically when I'm explaining the factory design pattern, I was doing same thing. So I'll just show you what exactly I did. So notification object. Yeah. So this is the notification factory, right? Initially I have created all the objects like push notification, email notification, SMS notification. So in the hash map, so whenever someone is asking, I was simply returning this instance, simply returning from my map. This exactly we can call it as Flyweight also. This can be called as both factory and Flyweight pattern. So let's see how I implemented. So I have a car. So car has name, speed and horsepower, and car is initially the constructor. This is an abstract class where constructor is applicable. And also car can move in the racing game. Car can be moved, right? So from current point to current x5 to new x5 coordinates. So car can be implemented by 2 different cars, like MC Learn car and also Porsche car. Here I'm overriding the move car. I'm just printing. Here also I was printing how many number of instances created for this particular Porsche car and how many number of instances created for the particular McLaren car. So I have a car factory where I has created a Flyweight. So whenever someone asks me to get race car, I was just checking if the car is already presented inside the car factory or not, Flyweights or not. If it is there, I was simply returning the reference object only. If it is not there, I was creating the car and then putting in the Flyweights and then referring. So whatever is doing in the notification factory, right, which is basically static, but this is happening in the runtime. So that is the only difference happening here and here. But this can also be converted into this one. There is no issue. So ultimately, Flyweight is something where we are storing the shared objects in a common hash data structure. Okay. So we are returning the car. So if you see the driver program, so I have initially I am giving the list of cars. So let's say I have a cars. So whenever I'm trying to add all the cars in the list of cars for the racing, so I'm getting the data from the I'm asking to give the object of this particular car from the car factory. Here every time it will go and it will check the cache. If it is presented, it will simply return. So this for loop, after this for loop, generally we are expecting 4 objects to be created, but here because of Flyweights which are caching the data, only 2 objects are created. So here whenever cars are moving, it is moving into next direction. So if you at last whenever you print the number of instances are created, right, it will create only 1 instance for each. If you run the program, it's building, and yeah. So current location of McLaren is 99, 51. It's moved to 47, 56. Same. So if you see here, this car is added. Next time this car is added, but it was not added new car. It was getting the reference of this particular car. Similarly for Porsche and Porsche. So now when you are running, right, it actually runs 4 times. So every time car is moving, there is no doubt about that. But it was not creating initially. It was not created objects 4 times. It was created only 2 times object. So at initially the car is at this location and car is moved at this location, because these are basically called extrinsic state, and the car object itself is called intrinsic state. That's why we are storing in a shared object, and these things are like we are passing as an argument to the shared object. That's the difference between intrinsic state and an extrinsic state. At last, if you see, number of instances created for McLaren car is 1, and number of instances created for the Porsche car is 1. This is a simple example and also simple way of explaining what is exactly flyweight car. What is exactly the flyweight design pattern. Anyway, I am sharing this link in description in the GitHub, in my GitHub, right? You can go and watch all these things, and you can download, you can play around the program, like. So only thing you need to understand is like what exactly flyweights means. It's nothing but a cache of storing the shared object. That's it. Apart from that, it's like normal how you written the program only. That's it. How you identify the shared objects, how you identify the extrinsic state, how you will pass the extrinsic objects into the shared object, so that it will improve the performance, it will improve the RAM efficiency. I think this is about like flyweight design pattern. In the next video, I will start the new design patterns called behavioral design patterns, and among them the first one is called chain of responsibility design pattern. So if you like the video, please share, subscribe, and please subscribe and share, and also like the video. So if you have any doubts, please comment. I will try to answer most of the comments. So we'll soon meet in the next video. For now, bye bye.